The purpose of this video is to teach you the basics of using a RAPTOR. You will have to download it and install it on your computer. You will need it throughout the semester. The link is located on Blackboard. Please download it, install it, and get familiar with the layout of the screen. So what I want to show you is the way that RAPTOR is laid out. You have the main designer window, we have our symbol window, and then over here we have this thing called the master console. The designer window, this is where we're actually going to design our flowchart. The symbols are symbols that we can put into our flowchart over here, and then any output that should come out of our program will show up in the master console over here. There is another pane over here which is where variables will be located. Anytime we have a variable, it will automatically show up over here, and the value that that variable is set to will show in the list. Now, what you should have seen from the other video is that a variable is nothing more than just simply a named place in memory. So we're giving a memory location a name, and then we're going to assign a value to it. Now, when we first create a variable, when we create that memory location, there's nothing in that location. And when we create it and we haven't actually told it what the value is that goes in there, that's called a null value, N-U-L-L. And a null value just simply means we have a memory location, we just haven't assigned any value to it yet. So we'll get to that here in just a minute. Before you do anything in your program, you need to save it. Now, what it will do is if I try to do anything to it, it'll pop up a little box that says please save now, and actually it will tell me every so often that I need to save, so that way I don't forget to save it and lose my program. So I'm going to go to File, Save As, and I have a folder on my desktop called CIT 120, and inside of here I created a folder called Week 2. The way that I am going to name these is with my last name and then an underscore, and if it's the weekly assignment videos, I'm going to put a W so I know which week it is. So it's Week 2, and this is going to be program number 1. Alright, so now when I'm designing the programs from the exercises from the textbook, what I would do instead would be something like page 29 underscore number 3. That way I can tell which program it is when you submit it. What you are going to do is you're going to take all of the programs that you design for your exercises, put them in one zip file and submit it to Blackboard. And I'm going to have to be able to open that up to be able to see what files you have inside of there, and if I can't tell which program is which, you will not receive credit for it. Okay, so this is my week 2 video, and it is number 1. So I have week 2 number 1, and I'm going to go ahead and save it. Now notice it will save with a .rap file extension. What I will also end up with is some other files in that same folder, and they are .bak files. Those are backups. If you submit a .bak to me, I can't do anything with it. I have to have the .rap file. Please be aware of that. I need the .rap file. Alright, so before I even start my program, now what I need to do is to provide a comment so that we can have some information about who made the program. Okay, so what I'm going to do is I'm going to right click on Start and then go to Comment. And what that does is it brings up a dialog box for me so that I can see what I want to put into here. So I'm going to put in my name. I'm going to put in that a CIT 120, today's date, so it's 8/22/2015. Oops, too many twos. That's a logic error, by the way. And then this assignment is week 2 video number 1. So that way, what that'll do is it'll show up right here beside that symbol that this is who designed it, this is the class, the date, and then I know what assignment it is. I want you to be aware that RAPTOR has functionality built into it that prevents cheating. There is actually a log that gets generated every time you create a RAPTOR program. And I will check these. To see the log, you come up to Help and then Show Log, and it actually shows who created the file, the name of the computer, what date you created it, and there is also a signature that is here. And this signature will vary based on what computer was used to generate the program. So please make sure that you're not copying somebody else's. If I catch it in here, you receive no credit for it. I want to design a program, and the most basic program that we design in any programming language is one that just simply outputs to the screen hello world. So to do that, I'm going to use an output. Now I have two ways to get an output into my program. I can either drag it over into the program where I want it, or I can right click on the line and insert an output. Alright, so I have two of them here. I want to get rid of the second one. I can either click on it, make it red, which means it's selected, and press the delete key on my keyboard, or I can right click on it and delete it. Alright, so what I want to do is I want this thing to output something to the screen that just simply says hello world. So I'm going to double click on this, and what I'm going to do is I'm going to type hello world. Okay, now the thing is that hello world is text, and anytime I want to get text to display to the screen, or if I ever want to do anything with text, I have to tell the system that it's text, and the way that I do that is I put it inside of double quotes. So now I have quotation mark, hello world, exclamation point, and then another double quote. And when I click done, I will get something like this. Now the thing is this is kind of small. It might be kind of hard to read right now. So what I can do is I can come up here where it says 100%, and I can make this larger. So now it scales it. So now we can see it a little bit better. It says put hello world. Now what it's going to do is it's going to put this out into this screen over here. Now there are two ways that I can run this program to see what it actually does. I can click the play button, and that'll start at the beginning and run all the way through the end. Or I can click this button here, which is called Step to Next Shape. It's also called Step Into. And so if I do Step Into, when I click on this, you'll see that the start turns green. Now the green symbol is the one that will run next. It's not the one that is already run. It's the thing that's going to happen next. So when I click on the Step to Next Shape, now it will run the start. Now start doesn't actually do anything. But now you notice that this put hello world is green, and it hasn't output anything over here. That's because this hasn't run yet. This is going to run when I click the button. So watch when I click this, watch the master console over here. There we go. So it just simply put hello world. Now notice it doesn't have the quotes over here because the quotes were just simply me telling the program, hey, this is text. Put this text out onto the screen. Now end is still green, which means it actually hasn't completed yet. Click it, and now the program's done. So what it will do is it'll tell you that the run was complete, and it tells you how many symbols were evaluated. So how many times did something turn green? And what that does is it tells us how many symbols are in the program, but if we expect it to do 5 or 6 different things, and it says that only 2 things were evaluated, then something didn't run correctly. Okay, so this is my first program, and we're going to call this our Hello World program. So what I want to do is I want to edit the comment. And I'm going to call it week 2 video, and then we're going to call it Hello World. Now we're getting a little bit more descriptive. It makes it a little bit more sense. Okay, now this thing here, we need to provide a comment for it, and the comment is going to be output Hello World. Now you'll notice that me putting output Hello World, this is kind of like doing my pseudocode. Because what I'm doing is I'm providing a step-by-step manner to show what the program is doing. So our pseudocode is just simply human language. That's for us to read through. But the comments are going to be the same thing. The comments are going to be there to walk us through. That we do this, then we do this, and this is why we're doing this. Alright, so that is everything for my first program. I want to make another one, so I'm going to come up here to the new icon. It's going to say it's going to delete the old flowchart. Do I want to save it first? Yes, I want to save it. And then I get a new one. Alright, so I have a new one. First thing I need to do is to save it. So save as. And this one's going to be Pringle _ W2 _ number 2. So this is week 2, number 2. So that way I know it's the video file. Save. And then also comment. Alright, so I'm going to say Brian Pringle. Okay, so this is week 2 video, and the program we're going to make is going to ask the user, sorry, I forgot to include CIT 120. The program is going to be the week 2 video, and what this is going to do is ask for a number and output a number. So ask for a number and output it. Okay, so now I know what the assignment is and what it's actually going to do. Alright, so this one's going to require for me to ask the user to give a number to me. And if they're going to give a number to me, then I need to put the number somewhere. And the only place that I have to hold on to a number that they give to me is in a variable. So we're going to play with a variable, And what I need to do is first get some input from the user, find out what number they want, and then output that number to the screen. All right, so I'm going to input and output. Okay, now notice the arrows. These do show input and output, even though the standard just simply calls for parallelogram. Okay, so here we are going to input, and what I need to do is I need to explain what they're inputting. Well, what I'm going to do is I'm simply going to put the variable name. Okay, so in this case, I'm going to call it my number, and I'm going to use a special casing. I'm using what's called camel casing, and camel casing just simply means I'm going to put all of the words that make up my variable name together as one long word, but the first word does not get capitalized, and all the other words are going to get capitalized. So I'm going to call this my number. And notice that my, the M, is lowercase and number is capital. So now what it'll do is if I have something like a really long variable name that has a whole bunch of words in it, I can see the beginning of each word along the way. So this is what I want you to do is I want you to use this, what's called camel casing, and we're going to create our variables this way. Now we will explain a lot more next week how variables work, but for the sake of this example, I have to at least show you this basic variable. All right, so I'm going to click done. And now the thing is it took my symbol and it put it here. Well, I can actually move these around. So now I can move my name out of the way. That way it doesn't interfere with this one. Okay, and then this one I'm going to output my number. Now I haven't actually created a variable. I'm just simply creating the pseudocode for it so that way I get an idea of what should happen with my program. All right, so in this one I'm simply going to double click and I provide a prompt here to ask the user to input a number. Okay, so my prompt is going to be what number do you want to input, or give me a number or something like that. Now, whenever I display anything out to the screen, if it's text, I have to specify it's text. So my prompt is going to say something like, give me a number. But if I say give me a number, I have to put it in quotes. So I'm going to put a double quote, give me a number. Okay, and then what we're going to do is we're going to tell them, hey, give me a number. And then when it prompts for a number, where are we going to put it? So down here is the name of the variable where that number is going to get stored. Well, what's the name of that variable? Well, we said over here in our comments in our pseudocode that we want to call it my number. So I simply type that name there and then done. Okay, so then I want to output that number in this one here. So I'm simply going to type in my number. Now notice when I started typing my number, anything that starts with an M that already is in the program will show up because it understands it. So if I type in my, here's that number, and I can use that number in my list here by just simply pressing enter. And then when I click done, now I get with something that looks like this. Now these comments are once again in the way, so we simply move them out of the way, but still keep them beside the symbol so that way we know which one they belong to. So give me a number, and we're going to stick that into my number. And then put my number, and we're going to output it on the screen. All right, so I'm going to run this, and then I'm going to give you one more thing that you need to do with it. So let's run it. We're going to do the step into. So the green will be the next one to run. So when I click this, it'll start the program. This one has not run yet. It's going to run when I click next. So I'm going to click the step into, and it pops up, give me a number. Now, I typed in give me a number in quotes. If that tells the system, hey, that's a text string, notice the quotes don't appear here. We're just simply using that to tell the system that it's a text string. Okay, so I'm going to type in 33, click OK, and watch what happens over here. It actually just took our variable called my number, and it assigned the value of 33 to that variable. Now, RAPTOR is not case sensitive. However, most of our programming languages are. So I typed it in my, and then number has a capital N. RAPTOR ignores that capital N and makes it all lowercase. In some of our programming languages, this and this would actually be different variable names, and I could assign different values to them. So just be real careful with your casing. In RAPTOR, it's forgiving. Other programming languages won't be. Okay, so right now it knows that my number is set to 33, and then it hasn't output anything yet, but I want it to output something in the screen over here, so I'm going to click next. And there's our 33. When it's done, it says run complete, 4 symbols evaluated, and it just simply gave us our output over here. Now RAPTOR allowed me to do something that you probably didn't think about, but most programming languages won't let me do this. I used a variable here before the variable was actually created. And if I try to do this in Visual Basic or C# or Java or a lot of other programming languages, it'll actually throw an error because this variable would have to exist before I can actually use it. So what I want you to do is I want you to assign that variable. We're going to create the variable. It's actually called declaring or dimensioning a variable. And what dimensioning means is that I'm creating a space in memory to hold the value. So how much memory am I actually going to use? Alright, so I'm going to use an assignment, and before I actually ran this input, I want to actually use that variable. So I'm going to create it. We're going to declare it. Alright, so this one is going to be declare variables. Okay, now what we do is if I had 10 different variables, I wouldn't have to say declare variables beside each one of them. Typically what we do is we declare them all in the same spot. So we put them one right after each other. And then we simply say declare variables at the top. So the very first one gets the comment. That way anybody that looks at it can see, okay, well all the things that are coming up are variables being declared. Alright, now I want to declare the variable. So what I'm going to do is double click on this. And what I want to do is I want to create the myNumber variable. And in most of our programming languages, we have to tell it what kind of data type are we using. Is it a text string? Is it a number? Is it an array? Is it what's called a float or a double, which are decimal places? Now RAPTOR uses just a couple of those. It does allow for strings, it allows for numbers, and it allows for arrays. It doesn't differentiate between something being a decimal number versus an integer, whereas C# we'd have to designate that something is an integer. All we have to do is simply set myNumber to be something originally. Alright, so what I'm going to do is I want to create the memory location for myNumber, and I want to declare it to be equal to 0. So I'm making the memory location and I'm actually putting a value in there, and the value is just simply 0. Alright, so when I click done here, now what I have is that I declared the variable myNumber, and what will happen is before we even get down to here, this variable will get created. So when I run this, right now it's going to take myNumber, create it over here, and set its initial value to 0. Now when I ask for a number, it will take whatever number I enter, replace the 0 with that number, and then now it's going to output that value. And the idea here is that I am declaring it first, so that way it already has a value. Now why do I want to do this? Alright, well, what will happen sometimes is the system may not understand if I want to create a text string or a number. And let me show you what would happen if I were to do something like that. Okay, so I'm going to go to myNumber. I just stopped it, by the way. I'm going to go to myNumber assignment. And I'm going to declare this as being a text string. And the way that I declare it as being a text string is by putting 2 double quotes in there. Now, what I am doing is I am assigning no value whatsoever to it, but I'm telling the system that it is a text string. Okay, so it lets me do that. It says myNumber is a text string. So when I run this, myNumber is equal to nothing, but it's a text string. And then when I click the next one, and it asks for a number, watch what happens when I try to stick a number into that value. Okay, RAPTOR lets me do it. Most of our programming languages would throw an error at that point. And if I try to do something like that in C#, the entire program would crash. So I have to be careful about how I declare these. Alright, so I'm going to set this back to being 0. Okay, let's say I were making a program where I wanted to count down from 100. Then what I would do is I would take myNumber and start it at 100. If I want to count up from 1 to 100, then I'd set myNumber equal to 1. So what I'm doing is simply giving myNumber a starting point. Alright, I want to modify this a little bit to make it look a little prettier, because right now it's just saying 35. Well, what is the 35? Alright, so I'm going to show you 2 different ways that I can make this say your number is, and what I'm going to do is I'm going to put another, sorry, not an input, an output right here before the output of myNumber. And what I'm going to do is in quotes, I'm going to say your number is, and I'm going to put a semicolon, a colon, and then done. And what this will do is it just simply give me a little prompt so I know what that number is. All right, so watch what happens. When I run this, we start off, my number is equal to 0. We ask the person to put in a number, 60. We stick the 60 into my number. We're going to output on the screen, your number is, and then the next one, it will take whatever's in my number and output that to the screen. Okay, so that works. The user can look at this and say, okay, well, that's what that is. The 60 is your number. But typically, we don't want to do that. We typically want to put that all in one line. And the way that we do that is through a process called concatenation. Concatenation means to take two things and put them side by side. All right, so what I'm going to do is I want to put your number is and my number side by side in the same output. So I'm going to take it out of here. So I'm going to cut it from there. Oops. And it's actually, I'm going to just simply copy it because it's going to expect us to have something in there. And I'm going to go in here to my number. And what I want to do is I want to put in here, I want to put this at the beginning. So I'm going to paste it. So your number is. Okay, so what I want to do is I want to put those side by side. And the way that I concatenate them is by putting a plus sign in between them. Now, a plus sign in this case does not mean addition. And the reason for it is this thing right here is a text string. So when I do plus, it knows, hey, this is a text string, and it will take my number here and convert it to a number also. To a text string. So I have a text string here with a plus here, which means that anything comes after it is going to be converted to a text string, and they'll be put side by side. All right, so I'm going to run this, and then I'll show you something that I need to fix on it. I'm going to delete the other output that said your number is. Okay, so I'm going to create the variable called my number, set the initial value to 0. I'm going to ask for a number, so 40. Change my number to 40. When we output this, watch the output over here. Okay, so it says your number is colon 40. All right, now what you'll notice is that it literally takes whatever we type in and put it side by side. The spaces got ignored. Okay, and what I mean by that is when I was in here, I included a space before the plus sign and a space after the plus sign. And I want you to do this. Every time you use a plus sign, you're going to put a space before and after. Okay, so what I'm going to do to force it to have a space is I'm going to go inside of my quote. So your number is colon, and I'm going to put a couple of spaces here inside the quotes. Now what this does is it will take whatever I type here and put it out on the screen here, which means it'll force two spaces before the 40 comes up. So now if I run this, ask for a number, so 50, output it to the screen, your number is, and then notice the two spaces actually show up this time. So you need to control your spacing by doing concatenation. There are other ways you can do that. Like I could take this and modify it a little bit. Like let's say I don't want the spaces inside of here. What I could do is I could actually put in another plus and then a set of quotes with a space in between them. So it would say your number is plus and then a space plus and then the number, and this is okay too, although it's kind of convoluted to run that way. So it gives me the same type of output. So I can take any amount of text and concatenate them side by side. All right, so I want to modify this a little bit more, and I want this to be a sentence. So I'm going to put this back the way that it was before. And instead of your number is, and then a colon, I'm going to leave a space here. I want it to be a sentence. And I want a period at the end. So to do the period at the end, I'm going to put a plus sign, and then in quotes, put the period. So now say your number is, that gets typed out to the screen with the space, plus whatever is in my number converted to a text string. It automatically does it, plus a period. Now I didn't put a space before the period because we don't do that in a sentence. We usually leave the period tied against the last word. So if I run this, 30, okay, your number is 30. So now I get something that looks more like a sentence. So it depends on the structure of what you need, but the process called concatenation is what allows me to do that, where I can put variables and text in the same string and have it type the whole thing out on the screen for me. Alright, so let's say I wanted to have this thing output on the screen 5 times. What I can do is I can copy these and I can paste it. So what I'm going to do is I'm going to put 5 of these down here. So if I scroll down, I have 1, 2, 3, 4, 5. Now my outputs are just simply that. They're going to repeat the same output 5 times. So I'm going to say, I'm going to play it so that way it runs all the way through. And give me a number, 50. Okay, now we're going to stick the 50 into that my number, and it will just simply output the same thing 5 times because I put 5 of these outputs. Now throughout the semester I'll show you other ways that are better to do this. But if somebody asks you to output the same thing on the screen more than one time, you just reuse the same output. Alright, so I'm going to save this, and I want to make a new program. So we're going to make one more program. And what I want to do is to show you some arithmetic that you can do within your programs. Okay, so I want to ask a user for 2 numbers, and I want to add those 2 numbers together and tell them the output of those numbers. Okay, so I'm going to save this first thing. And so this is Pringle underscore week 2 underscore number 3 dot wrap. It'll automatically put the dot wrap and save. And I need to make a comment. So Brian Pringle, CIT 120, 8/22/2015. This is week 2, and this one's going to be add 2 numbers. Okay, done. Okay, here's my comment. I'm going to move it out of the way. And so what I want to do is I want to ask the user for 2 numbers. So if I'm going to ask them for 2 numbers, then what I need to do is I need to create 2 variables, one to hold each of the numbers. So I'm going to put 2 assignments into my program. Okay, so I'm going to set what I'm going to call number 1 to 0. And then I'm going to set the other one, I'm going to call it number 2, and set it to 0. So I'm simply just declaring these variables. Alright, so I'm going to comment this, declare variables. Okay, now what I want you to do is I want you to get in the habit when you write these comments, I want you to put 2 forward slashes at the beginning. And the reason for it is that when you're actually in C# or in Visual Basic or other programming languages, the 2 forward slashes designate that whatever comes afterwards as a comment. And I just want you to get in the habit of doing that. So this whole section here is called a block. We're going to declare these as being variables declarations. Alright, I'm going to ask the user to input a number. So I'm going to say, give me a number. And we'll put that into number 1, as long as I don't type it wrong. Okay, and then the other one I'm going to say, give me another number. And remember, I'm putting the prompt in quotes, and I'm going to put it in number 2. Okay, so what I have so far is I've declared these 2 variables, which means they'll show up over here. Both of them will start off with a value of 0. We're going to ask the user for the 2 numbers. And then what I want to do is I want to perform a mathematical calculation. Now the assignment symbol is the one that we actually use to do that. So I'm simply taking my numbers and I'm performing a calculation. So I've asked the user for number 1, I've asked the user for number 2, and I need to output that to the screen somehow. The only way that I can do that is to take those 2 numbers and put them into a 3rd variable called answer or total or something like that. Now the problem is that total may actually be a reserved word. So what we're going to do is I'm going to create another variable here, and I'm going to call it my answer, just because I know my answer isn't reserved. Set it to 0. When we start getting into other programming languages, we'll start talking about data types and we'll start using different prefixes, but for right now this is okay. And so what I'm going to do is I want to take whatever's in number 1, add it to what is at number 2, and then stick that answer into my answer. Now the way that that works is we're going to say that my answer is equal to number 1 plus number 2. So what I'm actually going to do is I'm going to put it in here that we're setting my answer to number 1 plus number, and notice I can highlight those and press enter, and actually I did it too soon there. So what we're doing is my answer is going to be the thing on the left. Now the way that this works, the thing on the left is going to be the memory location that we are manipulating. So we're going to read in whatever's in number 1 and whatever's in number 2, add those together and stick them into the memory location called my answer. It will always be this way. Whatever's on the left side will be what the sum of these two numbers goes into. So this is the one we're manipulating. When we do this in another programming language, it would actually say my answer equals number 1 plus number 2. And the idea is that whatever's on the left is the memory location that we want to manipulate. Whatever's on the right are the values that we're reading in. Okay, so what we're going to do is we're going to declare these three variables. We ask for the two numbers. We add the two numbers together, stick that into whatever is in my answer, and then we're going to have an output. Okay, now I'm going to make this one a little bit longer. What I'm going to do is I want it to say the sum of whatever's in number 1 plus the sum of, the sum of whatever's in number 1 plus whatever's in number 2 equals whatever my answer is. And so I'm going to make it a little bit longer. So I'm going to say the sum of, and remember I got to control my spaces here, so I'm going to concatenate these together. So the sum of plus number 1 plus, and I need to watch my spaces again, so I'm going to put a space here, and space number 2 plus equals plus, and whoops, no, my answer, as long as I spell it right. Okay, and then I want to have a period, so plus and then a period. Notice I've just taken a bunch of things and concatenated them all together. So let me explain what it does. It says number 1, whatever's in number 1, it converts that to text. Number 2, whatever it is, converts it to text, and whatever is in my answer converts that to text. Then it will take the sum of with a space, put it beside the number, and then put a space and another space, put it beside number 2, put it beside a space equals space, put that beside whatever's in my answer, plus whatever is in here, which is our period. So we'll actually get something that looks like an answer. Okay, so I'm going to make some comments here. Input, we're calling it number 1. This one is input number 2. This one is add number 1 and number 2 and put into my answer. Okay, now I could have written that differently. Let's actually change that. I'm going to do my answer equals number 1 plus number 2. So now it looks more like a regular programming language. And then here's going to be our output. Okay, so I'm just simply going to say output, but we're outputting all of this. Alright, so if I step into this program, we're going to declare the three variables. So we now have all three of those listed here. Notice that Raptor puts them in alphabetical order. The next thing that we're going to do is we're going to prompt for the number. So I'm going to put in 3 for the first number, and then the next one we'll put in 5. Okay, now it comes down here to this one, and it's looking at whatever's in number 1. So what's in number 1 right now is 3, and it sticks it here. And then it looks at number 2, and 5 is there, so it sticks it here. So it's going to say 3 plus 5 equals 8, and it will stick it into my answer. So watch what happens to my answer when I step into this symbol. There you go. So now my answer is 8. Alright, so now on this one we're going to say the sum of whatever is number 1, so 3, and whatever is number 2, so 5, equals whatever's in my answer, so 8. And there we get an actual symbol or a sentence like that. So the sum of 3 and 5 equals 8. Now if I wanted it to be something like to multiply the two numbers, then I could change this a little bit. So instead of being a plus sign, we have other symbols we can use. We can subtract, which is just a minus sign. we can divide, which is a /, and we can multiply, which is an asterisk. So I want to multiply those two numbers together. So then down here, if I'm multiplying these numbers, then I'm going to have 3 times 5. Well, if I say the sum of 3 and 5 equals 15, that doesn't make sense. So I need to change my word down here also. So this time it's no longer going to be sum, it's going to be product. Okay, so now if I run my program, so 3 and then 5, it calculates that to be 15. So now the product of 3 and 5 equals 15. Once you're done with all of your programs, you need to submit them to Blackboard. So to submit it to Blackboard, I've created the folder called CIT 120, and it has week 2. Inside of week 2 are all of the resources that were used by RAPTOR. Now notice we have these backup files. I don't necessarily need the backup files, but if you submit them, that's okay. But what you're going to do is you're going to go at this level where you see the week 2 folder, right click on it, and then you want to send to compressed zipped folder. And what that will actually do is it will create a zip file that just simply says week 2. And the way that I want you to name this is going to be just simply put your last name in front of it. So this would be Pringle week 2. Press enter, and this file is what you're actually going to submit to Blackboard. If you have any questions, please let me know, and good luck.